Hi, this is Ms. Fazone, and this is amplitude and vertical shifting of trig functions. All right, let's do a quick review of graphing just sine to start with. All right, so where does sine start? Sine starts at 0, 0, 0, and then where else does sine hit 0? Pi and 2 pi, and it goes up and then goes down. Okay. So you really want to have a good handle on what this looks like, just this basic sine curve. That's what the homework was on. Now, I want to do it again, but let's think about what happens on the negative side also. So normally it starts at 0, goes up, goes down, down to -1, back to 0. But what do you think happens on the negative side? Does it go up? No, that would be awkward. We'd have kind of a corner here. We don't want that. So it's a nice smooth curve. Goes down, up, up, down. Okay. So that's the negative side, because that's going to come up at some point. All right. Amplitude. What do you think of when you think of amplitude? Well, an amp, think about sound. It makes it go higher. So amplitude, if you have y equals a sine theta or y equals a cosine theta, a is your amplitude. It stretches the graph vertically. Okay. It's kind of like if you changed the radius of the circle. Okay. Alrighty. Alright. So let's start with number 1. 2 sine of theta. 2 sine of theta. So how is this different? Well, it's got this 2 in front of it. So all it's going to do is it's going to stretch it up to 2 and down to 2. So we have our pi over 2, our pi, 3 pi over 2, 2 pi. So notice I said the word stretch. It still starts at 0. It still hits the zeros in the same spot. That's not changing. All that's changing is instead of going up to 1, it goes up to 2. Instead of going down to 1, it goes down to 2. So there's really no big change here with the amplitude. It doesn't change it, it just kind of stretches it up. Think of it this way. Pi over 2, sine of pi over 2 is 1, and you're multiplying that 1 times 2. Okay? So a lot of students get freaked out when they see fractions. Let's do a quick fraction. This is what's nice about them. We're just going to put on the graph what we want. I want 2 over 3. I'm going to put 2 over 3. Make sure you label, put these dashes. Sine is still, it goes 0, up, down, negative, back to 0. Looks exactly the same. We're just making sure it's going to 2/3 and not 1. Last one, negative sine. Let's do this over here. Y equals negative sine of theta. So what do you think is going to change here? Zeros. What's that negative going to do to the graph? Well, instead of going up to 1, where are we going to go? Down to 1. Just like every other graph we've done this year, a negative flips the graph upside down. So instead of going up first, it goes down first. Done. That's it. Okay? All right. Number 4. Y equals -2 cosine of theta. All right. So again, this is my 2 pi. 1, 2, 1, 2. Now, where does cosine normally start? It normally starts at 1. 1 times -2, -2. So cosine with -2, we're going to start down here. Right? Now, cosine goes from here, goes to 0, right? And then up, down, down. Remember, the points make a V shape. Do not draw a V, draw a curve. And that's it. That's your cosine curve. Number 5, 8 cosine theta. So this one's going to go up to 8. And I'm going to be super lazy, and I'm just going to draw a dash and make it 8. And that's what I like about these. We can be lazy if we want. 2 pi, pi, pi over 2. It's good to write these just to get used to them. All right, again, where does cosine start? It starts up, and then it goes down, down, up, up. Again, makes that V, and then draw your curve. It's U-shaped. Some students like to say it looks like a uterus. Okay. All right, last one, -1/2. So what is this going to look like? It's going to look just like this. Instead of putting a 2, we're going to put a half. That's it. And if you want, you can do 1/2. Sometimes I like doing that, -1, -1/2. Kind of to scale it. All right, where does cosine start? It's going to start at -1/2. Goes up to 0, up to a half, down to 0, down to a half, right? Makes that V. It's going to be upside down. And that's your graph done. Okay. All right, I have more, but we're going to skip those. We've done enough. What happens to the graph of sine and cosine when a number is added to the function? Well, think about this. If I gave you y equals x minus 3 squared plus 2, what does this do to the graph? It shifts the graph vertically. All right. So